Welcome to our next video, Rules of Exponents. Again, basically like a part 2, but this one is just cut and dry. We're going to talk about some definitions here, and we're going to do just minor examples. So we did already go through all of these rules. I just want to make sure that I really go through them again, so that way whenever you're studying with your flashcards, this process is a lot easier. So product rule, when I multiply, keep the base. Add the exponents. I cannot express to you enough how important it is that you're saying those things to yourself out loud, because that is going to be what helps you remember. When I multiply, keep the base, add the exponents. Perfect. Bases are the same. Therefore, I know that whatever answer I'm going to get, the base is going to be x. And then I know that 3 plus 5 is 8. Perfect. When I multiply, keep the base, add the exponent. On the flip side of that, when I divide, keep the base, subtract the exponents. Perfect. Now, again, bases have to be the same. That part doesn't change. I have x to the power of 4 divided by x to the power of 2. Bases are the same, so I'm going to have x to the 4 minus 2. If you need to see that, go ahead and write it down. But then you should be able to see, oh, that's going to be just x to the power of 2. The only thing I can really express to you on that one is please make sure that you are doing numerator minus denominator. Perfect. 0 rule. Any number or term to the power of 0 equals 1. As you saw in our last video, no matter what number I typed in to the power of 0, I always got the output of 1, just like that. So anything to the power of 0 is going to equal 1. The next one is the ones rule. Now this one we didn't talk about in the last video because this one is just kind of a thing you need to know, not something that's necessarily going to be star tested. But it does say any number raised to the power of 1 equals that number, or 1 raised to any number is always 1. So over here I have 5 to the power of 1. Let's come over here and type that in. 5 to the power of 1. And as you can see, we get the output of 5. So any number raised to the power of 1 equals the number. So no matter what number you have, if it's raised to the power of 1, it's going to just be whatever that base is equal to. And then the last rule said 1 raised to any number is always 1. So let's type that in. 1 to the power of 67 got me, it didn't give me 67, it got me a 1. The reason for that is because exponents mean repeated multiplication. So that is 1 being multiplied by itself 67 times. Therefore, 1 times itself that many times is still just going to give you the output of 1. So that is what the ones rule is knowing the difference of something raised to a 1 is going to equal the base, but then 1 raised to any number is going to just be the value of 1. The next one is the negative exponent rule. Probably one of the most important ones is when the exponent is negative, you take, oh, sorry, let me get my pen here. Take the reciprocal, there we go, sorry. Take the reciprocal of the base and the exponent. One thing that I want you to remember is that you always have to get rid of that negative exponent. You cannot leave a negative exponent in any part of your answer. So with that being said, we have x to the power of negative 2. I am not allowed to have that negative 2 situation. So if you remember from our last video, I have to compute the reciprocal of this. This entire term is currently written over an invisible 1. Again, it's not necessary. Mathematicians are lazy. If they don't have to write something, they're not going to. So whenever I compute the reciprocal of that to turn it positive, it's going to change it to 1 in the numerator now over x to the power of positive 2. And that is an acceptable final answer because I have an exponent that is now positive. Next one is power to a power rule. When I have a power to a power, what color am I using? There we go. Keep the base. Multiply the exponents. Perfect. Now, if you look over here, I have x to the power of 6 to the power of 7. Power to a power. Power of 6 to power of 7. When I have a power to a power, keep the base, multiply the exponent. So that x is currently the base. And then I have to now multiply 6 times 7. So now I know that the answer is going to be x to the power of 42. Now, obviously, these are just very simple one-step examples. We are obviously going to get into some combination pieces, but I really want you to understand the basis of what you're doing first. So now, power of a product rule. With this, we have when I have a power of a product, we are going to distribute the exponent to each term. Now, I didn't go super in depth in the other video on this because I knew that this one was coming up. Notice here, I have 2 times x times y. That is your product piece. But now you also have a power attached to this entire product because it's outside of that group. It's attached to everything inside of that group. When that is the case, I have to now share this exponent here to everything. Now, hopefully you remember that you're not sharing it to the base, you're sharing it to the base's exponent. So if you remember, everything that is just written by itself has an invisible exponent of 1 because mathematicians are lazy. Now, in the other example, we did not have a number that we shared to, which is why I'm glad to be going through this one with you. You have to also share that to that base of 2. So now when I rewrite this, I will have 2 to the power of 3. Notice I didn't put 6. I didn't do 3 times 2. I had to do 3 times the power of 2, which was 1, which is why I was able to do 2 to the power of 3. And then, of course, x to the power of 3, and then y to the power of 3. Now here, I did say in the other video, this is all about combining terms. I can still simplify this 2 to the power of 3. Whenever I go to my calculator over here, I type in 2 to the power of 3. It gets me the output of 8. So whenever my final answer, although this is acceptable, that is not an acceptable final answer. Oops, sorry y'all, one moment. That scared me. When I have 2 to the power of 3, that is going to be 8. I don't know what x to the power of 3 is because that's a variable. And then y to the power of 3. So this right here is the acceptable answer for that example because I have shared that 3. Let me move this. I've shared that 3 to the base of 2's exponent, and then I did the same thing with x and y. So that's probably the biggest misconception that we start to see is that we think, oh, we're going to share this 3 to this 2 and turn it to a 6. No. You are not sharing to the base. You are sharing to the exponent of the base. That is why they're called exponent rules. Okay? Now the next one, power of a quotient rule. Kind of went into this in the last one with the quotient rule, but now we have something being multiplied by a quotient versus having just the x to the power 4 over the x power 2, which is the example you see up here. Now I have a quotient that now has a power attached to it. And the rule is pretty similar to what we were already doing. So when I have a power to a quotient, we're going to distribute the exponent to the numerator and denominator. Okay, now with that being said, what I mean by that is, again, we are not necessarily distributing to the base. We are distributing to the power of the base. So if it helps you, go ahead and go label what those exponents are, so that way you have them and you know what you're doing. And of course, distribution just means to multiply. So we can rewrite this as x to the power of 1 times 8 over y to the power of 1 times 8. Now, obviously, that step is not necessary. I just put it in there so that way you can understand where this is coming from. So you have now x to the power of 8 over y to the power of 8. Exponent rules are not difficult. It is just something that we have to familiarize ourselves with, because again, we are just combining like terms, but now I'm having to do it a very specific way. And not only am I having to do it like that, I'm having to do it based on the exponents themselves, and the bases just kind of come along with it. So that is what this page is for. Hopefully this video helps. Please, please, please study your flashcards, and I will see you in the next one. Bye.